Friends, today we are going to explain the problems on the electrolytic conductance. First, I have focused on the some formulae, that is electricity, nothing but the current into time, and it is denoted by I into T. Then current equal to EMF upon resistance. The next formula, electrical work done equal to EMF into electricity, that is equal to E into I into T. Then power equal to E into I, that is equal to EQ upon T, that is W upon T. Then cell constant, it is nothing but the length upon area. The unit of the cell constant is per centimeter. The resistance equal to specific resistance into cell constant. Therefore, specific resistance equal to resistance upon cell constant. Then conductance equal to specific conductance into 1 upon cell constant. Therefore, specific conductance equal to conductance into cell constant. We know that the resistance is inversely proportional to the conductance, and conductance is inversely proportional to the resistance. The equivalent conductance equal to specific conductance into volume, that is equal to specific conductance into 1000 upon concentration. The concentration are taken in terms of normality. Therefore, equivalent conductance equal to specific conductance into 1000 upon normality. Then Cole's law. We know that Cole's law at infinite dilute solution is ion magnet independently. Therefore, equivalent conductance at the infinite dilution equal to sum of the equivalent conductance of the is ions. Then transport number of the cation equal to current carried by cation to that of total current. That is velocity of the cation to that of total velocity. Similarly, transport number of the anion equal to current carried by the anion to that of total current equal to velocity of the anion upon total velocity. Then transport number of the cation plus transport number of the anion equal to 1. We know that degree of dissociation lambda upon lambda 0, and dissociation constant for weak acid or weak base K equal to alpha square C upon 1 minus C. Now let us discuss the first problem. 0.5 normal solution of a salt surrounding two plates of electrode 1 cm apart and 0.25 cm square in area was found to offer a resistance of 475 ohms. Calculate the equivalent conductance of this solution. First focus which things are given. 0.5 normal solution, therefore normality is given, therefore normality means N equal to 0.5 normal. Then 1.0 centimeter apart, that is length L equal to 1.0, and area of the cross section area of the electrode 0.25 centimeter square, that is denoted by A. The resistance denoted by R 475 ohms. Then I am asking the equivalent conductance of the solution. So friends, we know that the first determine the specific conductance. Therefore, specific conductance equal to conductance into cell constant by using equation number 7. But we know that conductance is inversely proportional to the resistance. Hence, cell constant upon resistance equal to specific conductance. Resistance are given, that is 475. Therefore, this equation converted into resistance form, and cell constant nothing but the L upon A into resistance. Therefore, putting the value of L, A and resistance to becomes 1.0 upon 0.25 into 475 to give 8.42 into 10 to minus 3 per ohm per centimeter, that is unit of the specific conductance. Then to determine the equivalent conductance, the formula is known specific conductance into 1000 upon C, but C that the concentration are expressed in terms of normality, and normality is given that the 0.5 normal. Therefore, putting the value of specific conductance as well as normality in this equation, the equation becomes 8.42 into 10 to minus 3 into 1000 upon 0.5, that it gives minus 0.5. minus 16.84 per ohm centimeter square. The second problems. The resistance of a conductivity cell filled with 0.02 normal solution of an electrolyte is 1000 ohm at 25 degrees Celsius. Calculate the specific conductance and equivalent conductance if cell constant is 2.06 per centimeter. That is a correction, unit is per centimeter. Friends, that is similar way to solve the problems. The first given normality is given, that is equal to 0.02 normal. Cell constant is also given 2.06 per centimeter, and resistance, that is 475, resistance is 100 ohm. Therefore, to determine the specific conductance, similar formula are used. Specific conductance equal to conductance into cell constant. Therefore, cell constant upon resistance, that is inversely proportional to the conductance. Therefore, here upon into resistance, they are putting the all value in this equation. Therefore, gives value of the specific conductance, that is equal to 2.06 into 10 raised to minus 2 per ohm per centimeter. Now, determine the equivalent conductance by the same way. Specific conductance into 1000 upon C. C is the normality. Therefore, putting the value of normality in this equation as well as specific conductance 2.06 into 10 raised to minus 2 into 1000 into upon 0.02. Therefore, use the value of the equivalent conductance. Now, focus on the third problems. This problem based on the Gauss law. At 25 degrees Celsius, the equivalent conductance at infinite dilute solution of sodium acetate, hydrochloric acid and sodium chloride are 90, 425.15, 124.9 per ohm centimeter square. Calculate the equivalent conductance at the infinite dilute of acetic acid. If equivalent conductance of acetic acid of 0.001 normal solution is 9.23, calculate the degree of dissociation of acetic acid at 25 degrees Celsius. Now friends, first write down the given things. The equivalent conductance at the infinite dilute solution of sodium acetate, that equal to 90, not the 90.425, only 90. For HCl, that equal to 15, and for NaCl, that equal to 124.9. Then equivalent conductance is given 9.23 per ohm centimeter square. Now, though we know that with the help of Gauss law, the equivalent conductance at infinite dilute solution of acetic acid is equal to sum of the equivalent conductance of the anion. Anion means CH3CO minus plus S plus. Therefore, similarly, for sodium acetate, that is equivalent conductance of CH3CO minus plus equivalent conductance of Na plus at the infinite dilution. That is considered equation number 1. Now, equivalent conductance of HCl at infinite dilute solution equal to equivalent conductance of S plus plus equivalent conductance of the Cl minus at the infinite dilution solution. That is considered equation number 2. Now, equivalent conductance of the sodium salt NaCl, then equivalent conductance of the Na plus plus equivalent conductance of the Cl minus. That is equation number 3. Friends, but I want the equivalent conductance of the acetic acid at infinite dilute solution. Therefore, CH3CO minus plus S plus. Therefore, arrange the equation to give the value of CH3CO minus plus S plus and to give total equivalent conductance of the acetic acid at the equivalent at the infinite dilute solution. Therefore, equation number 1 plus equation number 2 minus equation number 3. To we get the equivalent conductance of the acetic acid equal to equivalent conductance of the CH3CO minus plus S plus. But what is the value of the equation number 1, that is CH3CONa, and CH3CONa value is given 90. For equation number 2, the value of HCl is given, that is 15. And for equation number 3, the value of NaCl and NaCl value is given, that is 124.9. Therefore, putting the all value in this equation and to get the value of the equivalent conductance of the acetic acid at the infinite dilute solution. Therefore, 90 plus 425.15 plus minus 124.9 to give 390.71 per ohm centimeter square. That is the value of equivalent conductance of the acetic acid at the infinite dilute solution. Now, asking the calculate the degree of dissociation of the acetic acid. We know that the formula for degree of dissociation, that is alpha equal to lambda 0 upon lambda 0. So putting this value in the equation, therefore equation, we know that lambda is given 9.23, lambda 0 is calculated now, therefore 390.71, therefore alpha equal to 0.0236. Now dissociation constant is also determined with the help of this formula, K equal to alpha square C upon 1 minus C. Friends, thank you so much. In the next video, I will focus on the investigation of the molecular structure, and take care.